Hello?
Hi, hello. Is your refrigerator running?
Let me check.
This is so funny.
No, it's just sitting there. It's not doing anything.
Wait. Dude, you're supposed to say yes, and I'm supposed to, like, say the joke where it's like, go catch it, and then, bro, you there? Hello?
But it doesn't have to. It could be running. I'll call you
Wait,
back.
what the heck?
Dude, get this text out of the way, man. Okay, so here's the plan. If I want my mini fridge to run away from me, there's a number of things that I'm gonna have to program and build for it to do exactly that.
All right, let's set some goals. First off, it's got to move under its own power. And then second, it has to see. It has to know where I am and where the world is. Okay, and then third, it needs to decide. It should choose to chase me or run away from me. And then fourth, it needs to not die, so it needs to go around stuff instead of into stuff. And 5, it needs to serve. If I catch it, it needs to open its door and give me a drink. Hey, let's do this. 30-second build montage. All right, that was a little much, so let's start breaking this thing down. It's essentially a little bit like an RC car, but with a lot more components. So how did I even come up with this? Originally, this robot wasn't even gonna be a tank. The first idea was to put legs on the fridge. If you remember my hexapod chasing video, I was basically gonna put that hexapod base underneath the mini fridge, but not only did it not really fit, but it also didn't really make sense. Honestly, I thought about it for more than 4 seconds, and a walking fridge that shakes every single drink inside of it, that sounds more like making a bunch of soda grenades, and so I went with a tank base. Tanks look cool and tanks work. Decision made. Now, my first version of the treads, I tried to design for 3D printing, like all of it. I wanted it 100% 3D printed, which is a cool idea until you remember, I kind of want this tank to go fast, and printed plastic treads at speed just turned into a very expensive bag of loose parts. So I did the responsible engineering thing and just bought real ones. In the modern age of capitalism, you can basically buy anything from Amazon, so there was an option readily available for tank treads for a robot of this exact scale. The treads and the supporting wheels bolt onto a metal sheet, and I needed to print a whole body around it so that it perfectly matched the bottom of the fridge. And that shape was weirdly organic, and there wasn't any easy way to measure it, so I cheated. Well, correctly. I 3D scanned both the metal sheet itself and I 3D scanned the bottom of the fridge, and I pulled both scans into Fusion 360 as a reference, and from there I could design the inner core of the tank so that the spacing matched and the treads mated into the fridge without guessing a single dimension. Then I mounted the first version of these treads and kind of tested it, which just meant rotating it by hand, but everything worked. Anyway, the drive motors that actually run the treads themselves are Repeat Robotics Ultra Mark II brushless gear motors. I know that's a mouthful, but these motors are ridiculous. They are 12-pound combat robot motors on a fridge. I did one full power test with no treads attached and immediately decided I would never do that again without some kind of safety shield. So I had to write in a bunch of limits in the software for the max speed, minimum speed, and that kind of thing, because a fridge that does a wheelie isn't really a feature, it's more like a disaster. And yeah, later on we're going to talk about how much I had to limit it because the number is genuinely funny. So now I had the shell of a robot that could drive around, but there was one thing missing, a door that opens itself. Objective 5 was to serve a drink, which means the fridge has to open its own door. So I built this little linkage off to the side of the door driven by a 25 kilogram servo, and for this mechanism to actually work, I had to rip out the latch from the door and replace it with magnets so that it could be pulled open using the servo. This whole thing was actually pretty tricky to get right, but eventually I had it working. I also rewired the internals of the fridge to run on 12 volts. I usually keep it off because it consumes a lot of power, but when I want to deliver something cold, I can definitely do that. Alright, so now we basically have all the pieces. We have the printed core, the scary tank treads, and the motor-driven door, all of which definitely works as intended. That's one big step done. We have a fridge that can move, but now we have to give it autonomy, which is probably a big mistake. I don't have a great track record with giving my robots autonomy and them not wanting to kill me.
Fun? You dare to call this fun?
I'm gonna do it anyway, but how do I actually get it to run away from me?
For the fridge to run away from me, it needs to know its spatial positioning in real time, and that's where the sponsor of this video comes in, Manifold Tech. They created the Odin 1 spatial memory module that's attached to the front of the robot and gives it live feedback for spatial positioning.
Like I said before, the Odin 1 is a spatial memory module. It's got solid-state DTOF depth sensors, an RGB camera, and an IMU, and it runs Manifold's own slam-on device, which means it isn't just seeing depth, it's building and remembering a map of the space as it moves through it. On my build, it's mounted to the front, and it's doing a lot of the heavy lifting. It gives me live odometry, where the fridge is and how it's moved, plus a real point cloud I feed straight into navigation, plus the front camera feed I actually use to find and track a person. It talks over a single USB-C connection, and after you get the drivers and stuff figured out, it's really straightforward, which was super nice after how much work I spent on the hardware. If you're working on a robotics project that needs high accuracy vision systems, this might be one of the best options you can pick from. Alright, so we just gave the refrigerator eyes so it can see its targets and enemies. I don't know if this is a good idea, but the next thing we should do logically is give it a brain. The brain or computer going into this robot is going to be the Jetson or a Nano Super, and we're running ROS 2, the Jazzy release, because it matches the Ubuntu version. The Jetson is essentially the brain of the entire robot, and then the ESP32 is kind of like a spinal cord. It sends out signals and prevents some bad stuff from happening. It honestly took longer than I'd like to admit to learn ROS, but I was doing it from scratch through YouTube tutorials, which are mostly outdated. Regardless, I was able to build out some interesting systems. Very similar to some of my other projects, I build out this kind of net of electronics that all communicates together and runs crucial software. For example, the NVIDIA Jetson is running a nano version of the YOLOVision model for person tracking, and I export the model to TensorRT so that it's running on the GPU and not the CPU. And that GPU part is not a flex, it's a strategy, because I need the CPU for navigation later. So vision lives on the GPU and driving lives on the CPU, and the two never fight each other over the same dinner. Alright, so there's a lot of infrastructure here, but we need to talk to the motors, and as I described before, the spinal cord or the ESP32 is the part that talks with the motor ESC and can actually send motor commands. The Jetson talks to the ESP over serial using a 4-byte message. It's a sync byte, a left speed, right speed, and a door command. 100 means stop and 0 is full reverse. 200 is full forward. It automatically resyncs itself if a byte is ever dropped, so a little bit of noise won't make the fridge jump or lurch around. Now for the door servo, and originally I ran the servo straight off of the ESP32 and it fought me. It turns out ESP32's servo library only has so many internal timers. I knew this from all of my previous encounters with this internal timer issue, but I just bit the bullet and added a PCA servo driver into the system. Okay, so next up is decision making. I've basically set it up so it can be manual, auto, or semi-auto. Semi-auto is really unique because in theory it's like assisted teleoperation. It's kind of like a backseat driver that's actually helping. It uses the front camera to chase me and the rear camera to run away from me. It's basically the same system but inverted for the front and back. Alright, we're finally on to objective 4. Not dying, and this is where it gets real. I brought in Nav2, the standard ROS navigation stack, and it takes the point cloud from the Odin and builds a live map of what's immediately happening around the robot. It plans a path that goes around obstacles, and then there's a translator positional node that I had to write because Nav2 doesn't actually really know how to follow people. So in follow mode, it sets a goal about a meter short of where I am. And in flee mode, it sets the goal in the opposite direction, updating as I move, so it's constantly plotting an escape route from the moving threat, which is me. I'm the threat. One other nice touch is that I made a velocity smoother node which sits in between the controller and the planner and basically smooths out the aggressive motors, meaning the fridge won't launch forward with everything inside of it, but this only applies to semi-auto and auto. In manual mode, I get the raw unfiltered experience so I can drive it around as much as I want.
Yo, it did a wheelie.
Alright, now we're finally on the last piece, control. And I didn't want a laptop tethered to it, I thought that was a little jank, so the NVIDIA Jetson serves a little web page. I pull it up on my Steam Deck and the deck's own joysticks and buttons drive the robot through the browser. This page shows me live telemetry and the robot's iView camera. So here's the final setup. I'm chasing my refrigerator across a yard, holding a handheld gaming PC, watching what the refrigerator sees with a giant red stop button under my thumb, just in case anything decides today is the day. Anyway, I was making great progress on the project, and then a random side quest popped up, and I'll let it speak for itself.
We are here at OpenSauce 2026, and
So yeah, I did a giant booth at OpenSauce 2026, and I'll have a big video on that later. What's more important is that I made a small customization to the tank while I was here.
honestly, I think it's missing something. Let's go drive this thing around. Be free! Yo.
I drove this guy around the whole event, and it was really funny. I built this super complicated navigation system, fully autonomous, all these cool things, but the number one question people had for the robot was, does it have beer in it? I mean, that would have been funny, but instead, I just put sesame inside.
That was insane.
I swear nowhere else, at no other event, can you drop your Sesame robot out of a fridge and show it to Michael Reeves, so OpenSauce was incredible. At around this point, I had gotten back from the event, and the robot has sustained some major damage. As much as I wanted to completely ignore it and go right on to testing, figured I might as well take the opportunity to redesign some of the parts and print it a little stronger. So I got a little ambitious and printed the entire thing in ABS, and then figured out how to do vapor smoothing, and vapor smoothed the exterior of the robot, and then I reassembled everything, sanded a bunch of more features, some motors, 10 other project guards with designs on them, brake light. You get the idea. I basically rebuilt the entire robot, but I'm so glad I did because it looks better than ever. Alright, now I thought it was ready to run away from me, but then I brought it out and it just wasn't working. I took notes, I assessed what needed to change, and I put my head down and kept working. See, with projects like this, even if you hit a setback and it feels like nothing's gonna work or you're gonna miss your deadlines, it's important to just assess the situation, set goals, and keep going.
lost me.
So let's recap. How did we do on our 5 goals? Well, we hit 5 for 5. I built a mini fridge that can see me, decide how it feels about that, and drive itself around obstacles, run away from me across a yard, and reward me with a beverage when my cardio pays off. And we achieved the 6th secret goal, making thousands of people at my favorite convention genuinely happy. That one wasn't on the list, but it turned out to matter the most, and it cost $2 in googly eyes. So what's next? Well, this thing isn't done. It's filmable, which is different. Here's where it's going. One of the biggest things I've wanted to implement is Smart Summon, using ultra wideband. Right now, everything is line of sight. The second I hide fully behind something, the cameras lose me. The fix is UWB or ultra wideband, basically radio time of flight. I wear a little tag and the fridge gets my range and direction even through furniture, walls, and my own body, which means Smart Summon. I press a button and the fridge navigates through its environment to wherever I am in the house. A refrigerator that comes when called. It's a little bit like a cold rectangular dog. The other feature I want to add is persistent target ID. Right now it locks onto the closest person for every frame, so in a crowd, it'd cheerfully switch between people to whoever steps in front. OpenSauce proved this instantly, and I never actually turned on the autonomous mode because I knew it would be a little chaotic. The third feature I'd love to add is a global map. Right now it only knows its immediate surroundings, but letting it build a global map, like something like one of those smart Roombas, would allow you to set destinations, such as charging points, or perhaps meeting someone at a couch. And there's so many... Wait, hang on. I think I'm getting a call.
I'm gonna get on this topic.
Yo, what's up?
Is your refrigerator running?
Yeah, of course it's running.
What? No way.
Yeah, and you should run too.
No.
Huge shout out again to Manifold Tech for sponsoring this video and giving the tank fridge eyes. As per usual, this entire project, including all of the files, source code, and a lot more documentation, is 100% open source. And as I said before, there's lots of things I'd like to improve on this project, so hit subscribe, and maybe I'll make a future video on it.